All right, so with our last lesson for Unit 3. So we are here and we're looking at the validity of our statements. On our last video, we looked at using the bad row method to help us to determine the validity if something was valid or invalid, if our arguments were valid or invalid. So now what we're going to do is we're going to look at our Euler circles and looking at our quantified statements and how they look using that method, right? Looking at using our Euler circles with our quantified statements and how we're going to see if something is valid or invalid by examining how those look. I'm going to do a quick little flashback for us to make sure we remember what we're looking at as far as our Euler circles. And again, on your memory sheet, you should be looking at or paying attention to what we learned. And this is back on our very first page when we were looking at our Euler circles. I'm going to go back here and then I'm going to share my screen with you. We are sharing. All right. So here we are on page 50 of our notes when we went over our Euler circles. Okay, so remembering that our quantified statements, all are, none are, some are, and some are not. And remember how they correspond to our circles, where all B's are A's, which represent that the last statement, A's, is the larger circle, and then the B is the smaller circle inside. So all these B's are A's. And then we had the two interlocking circles that represented our sum statements. So some A's are B's, that was here in the middle. Then some A's are not B's, was here in just the A part. Also, we could say some B's are not A's, so that would be over in this part, okay? And then we also had where we had two circles that were not touching, represented our none are, which is no A's or B's. So again, you'll be need to be able to draw these circles that correspond to your quantified statements, or be able to tag the statement to the circles to describe what's happening. So that's what we're going to do. We're going to be drawing these circles according to the situation that they give us so that we can see if our statement is, or our argument is valid or invalid. Okay, here we go. All right. We are on page 58. All right, so it says if our argument contains quantified statements, we use the second type of argument, our Euler circles. Let's read what it says. All snakes, some green things are sticky. Therefore, some snakes are sticky. All right, let's put a pin in it. All right, our goal here is to draw exactly what they give us. The first premise, and then draw the second premise according to the first premise. And then we are looking to see if our conclusion comes out to be true. Now, our job is not to make the conclusion true. Let's clear this up. Our job is not to make the conclusion come true. Our job is to see if we can come up with a counter example that shows that there's a way that we can draw this first premise and second premise that could show a way that this conclusion could possibly not be true. All right, if there's one counter example, that shows that we can draw, right, and show that this conclusion does not come true every single time, then this is not valid. All right, that's our goal. Let's see. Step one. Let's get some steps here going. Everybody likes steps. Draw the first premise. Whatever it is, draw it. So remember, this is P1, P2, conclusion. So your first premise, you can only draw it one way. Whatever it is, that's that one way. All snakes are green. Remember, all are is when you have one circle inside of the other. So we know we're going to have a big circle labeled green. Big circle, little circle. Okay? So big circle, a little circle. Big circle is green, and inside is snakes. This says that all snakes are green. Okay? All snakes are green. Now here's my second step. When we read our second step, our premise 2, it says some green things are sticky. Some green things. We have to think in our mind. Some green things means that we have to have another circle that's just touching our green circle. So in our minds, we should see more than one way, okay, to do it. So since all right. So I said, since there are a few ways we can draw premise 2 along with our premise 1 that we just drew. I'm just going to make a couple of copies of premise, our step 1. That way we'll know what we're doing, okay? Just going to make a few copies. Start off with 3. If we could think of some others, we can make some more copies. So I'm just going to redraw this right here, because I know there's a couple of ways I can see right now. A couple of ways I can draw some things are sticky according to this. Now you're not going to draw a whole nother set of circles here. All right, you have to draw it in conjunction with your first premise. So here, I'm just going to draw this here. So I'm just going to put SN for snakes and green. All right, so here's our first premise. My second premise, some green things are sticky. So if some green things are sticky, that means I need a circle labeled sticky that's going to come in contact with the green circle. So if I drew my sticky circle like that, this says some green things are sticky, right? It's overlapping with the green, and some green things are sticky, right? But I could also draw it like that. Isn't this also saying some green things are sticky? It just has to come in contact, right, with the green circle. Doesn't say that it couldn't come in contact with other stuff that's in the circle, right? But it just has to come in contact with the green circle. What if I drew it like this? Let's see. What if I drew it like that? That says some green things are sticky, right? It's coming in contact with the green circle. It's now overtaking the green circle. I'm keeping my eye focused on some green things are sticky. Does everybody see that? I just drew my second premise 3 different ways here, according to my first premise. Do you see what I'm doing? I'm thinking outside the box, so to speak, of how can I draw my second premise according to this first premise. The first premise isn't a problem. It's going to be exactly what it says. But the second premise, how can I draw it to where it says exactly what it says? Some green things are sticky. All right, I did it the first way. Some green things are sticky, but then I could think of another way to draw it, and it still says the same thing, that some green things are sticky. And then I thought of another way. I can draw that says some green things are sticky. Okay? Now let's look at it. I think I got my answer. Here's my step 3. I'm just thinking about all the ways I can draw it. And then I'm going to see, out of the ways that I drew it, is it saying my conclusion? Are all 3 ways coming up with my conclusion? Now, if it comes out to be true for my conclusion, I'm good. But if one of these ways come out to be false for my conclusion, then this isn't a valid statement. That proves my TTF pattern. You see how it comes to light even here in our circles? That's what we're looking for. Okay, so now here's step 3. Step 3 says draw, well, this is our step 3. Step 2 was to draw a couple of different ways of doing it. You know, we drew the 3 ways, but this is step 2 and our step 3. Step 3 says to finish off our steps. Okay, That's what we did. We took and we drew everything that we could think of, every way that we could represent our premise 2 according to that premise 1. Okay? Now we got to evaluate it. So now we got to ask ourselves some questions. Finally, we're going to look at our results and we're going to ask, do any does any diagram in our step 3, any one of these ones that we drew, does it support our conclusion? Okay. But then we're going to see, does any of them not? Let's see. Our conclusion says some snakes are sticky. Okay, some snakes are sticky. Let's see. Let's see which one supports that. Some snakes are sticky. Look, our second one right here supports that. Our conclusion, some snakes are sticky. Doesn't this say some snakes are sticky? That one says it. This is our conclusion right here. Okay. But do we have a counterexample? So our answer says, does the diagram in step 3 support any other conclusion? Yes. The second one does. Right? But oh, let me go back. That one's the only one, right? But do we have another? But okay, here's the real question. Do we have at least one, whatever you draw, do you have at least one that does not support our conclusion? We got 2 actually. But we have at least one. Yes. If you say yes to this question, there invalid. It's invalid. We found a counter example. Counterexample that shows that Doesn't have to be true every single time that some snakes are sticky. Because this first example right here shows us that no snakes are sticky. So it's not going to be true every single time. Does everybody see that? So we have a counterexample. Right? Invalid. So what's our goal? Our goal is to find at least one counterexample that shows something different than the conclusion that they're giving us. And if we do, statement is invalid. Okay? Now, I want to spend a little bit of time on this one so we can kind of make sure we see what's happening, understand what's going on. Let's give it a try. Some examples. Let's look at this next one. All snakes are green. All green things are sticky. All snakes are sticky. Okay, so we've read it. Now let's draw it. Draw your first premise. All snakes are green. So we know we need that big circle that's green and snakes inside. So here's that big circle with a little circle inside. This is green. Make sure you label correctly. And snakes. So we drew our first premise. Now we need our second premise. All green things are sticky. So now all green things are sticky means that we need a larger circle labeled sticky, but it's going to be all around green. So now we need a bigger circle. And this is going to be labeled sticky, because this says all green things are sticky. Okay? Therefore, all snakes are sticky. So now, if you're a snake, would you be sticky? Yes. This is the only way that we can draw this depiction of premise 1 and premise 2. There's no other way we can draw it. So our conclusion holds to be true that all snakes, all of them are in here, are sticky. So this is valid. Okay? Do we see it? It's the only way we can draw it. There was no other way we can think about it or envision it or see it. And in the conclusion that they gave us, the only one that can be true, this is it. All right? Let's try the next one. All snakes are green. Mrs. Massey is green. Therefore, Mrs. Massey is not a snake. Okay, let's draw our first one. We know what it looks like. So we have green and snakes. So here's green. Snakes. That's our first premise. Our second premise says Miss Massey is green. Now you notice this is not a quantified statement, so you can't make a circle out of Miss Massey. Miss Massey is just like be a dot or an asterisk or something. Okay, she's not a circle. So it says Miss Massey is green. So Miss Massey is green. If I think about it now, Miss Massey just has to be in the green circle, right? So we put her here. I'm gonna put a dot here and I'm gonna label it M. That's Miss Massey right there. Miss Massey's green. She's green right there. But I can think of another way of drawing it. just redrawing my first premise. And Miss Massey can be in here because in there, she's also in the green circle, right? Let me see, is there any other way? Nope, that's the only ways I can think of. Now you might think of some other way, okay? But I think that's all the ways I can think of, okay? So now, therefore, Miss Massey is not a snake. Now, Miss Massey is not a snake. This shows Miss Massey is not a snake. But this example that I drew shows that she could be a snake. She is in the green circle. Miss Massey is green here. But she could be a snake here. Do you see that? This is a counterexample from the conclusion here that they gave us. So because of this, this is your counter example. It makes this statement or argument invalid because there's a possibility that she could be a snake. Does everybody see? Don't think with your mind. Like you're thinking, you're putting in your own feelings. Like, well, hey, if I put her in the circle with the snake, then she's gonna be a snake. Okay, she might be, but you're putting her in anywhere in there, she could be green. So your focus is, where can she be green? Okay, so she can be green here, and she can be green inside here. Just so happens that she's inside the snake circle, but she's still green. Okay, so your focus is, where can she be green? And then, does this statement hold true based on where she can be green? Is Miss Massey not a snake? Okay, she's not a snake right here. She's good. But right here it shows that there's a possibility she could be a snake. She could be a snake and she could be a green snake. All right? That's not what we want. They're saying that she is not a snake. But here she is a snake. Okay? So we found an example where she could be a snake, invalid. Right? Try the next one. Pause the tape here and see if we can get through D. Right? Only draw the premise now. Okay? All right, do you think you got it? Okay, let's see. It says some snakes are green. Miss Massey is a snake. Therefore, Miss Massey is green. All right, let's draw the first premise. Some snakes are green. So we know we should have two circles just touching that. And so some snakes are green. So one is snake and one is green. Okay. So here we have some snakes are green. Miss Massey is a snake. So Miss Massey is a snake. Think about it. She's a snake, she could be in here, right? But I also see where, draw circles again. So this is snakes. This is green. Miss Massey could be in here. She's a snake in here, isn't she? Okay. As long as she's somewhere in the snake circle, she's a snake. Let's see, and draw it anywhere else? No. Both of these say that Miss Massey is a snake. All right. So now, both bring conclusion to be true. Miss Massey is green. Okay, she's green over here. That would be great. But over here, is she green? No. Here, we found our counterexample. Thus, our argument is invalid. Does everybody see what we're doing? Think about, you're drawing your first premise. Then you're going to draw your second premise according to your first premise. And draw it as many ways as you can think of. And then you're going to look to see, does your conclusion hold true for all? Okay? If it does, then it's valid. But if you have one counterexample that you have drawn that does not support that conclusion, not valid. Okay? Go ahead and try these other two. Give it a try. We'll come back and check it. You can get fun if you let it. Okay. All right. So now let's take a look. E. Do we say valid or invalid? Okay, I hear some mixed ones. I say invalid. Let's take a look. It says no dogs are brown. Miss Massey is a dog. Therefore, Miss Massey is brown. So let's draw no dogs are brown. So we have no dogs are brown should be two circles not touching. We have dogs and brown. Right? Then it says Miss Massey is a dog. She's in here somewhere, right? I think that's the only way we could draw that, right? Because she has to be in the dog circle for her to be a dog, right? Okay. Then, therefore, our conclusion, Miss Massey is brown. Miss Massey is brown. Is she brown? No, she can't be brown. Clearly, she's not brown. This isn't true. Here's a counterexample right here. The only way we can draw these two premises clearly shows that our conclusion is not even true. Invalid. Right? Invalid. Okay? And then for F, it says some dogs are brown, some pigs are brown. Therefore, some dogs are pigs. Let's give it a shot. Some dogs are brown. So we need two circles touching. One is dogs. The other is brown. All right. Then our second premise says some pigs are brown. So some pigs are brown means that I need another circle touching the brown circle, right? So at least touching the brown circle. And this is going to be called pigs. Now, can I draw this any other kind of way? You know what? I can see, I know some other ways that I can draw this, but do I have to? I don't even have to. Look at the conclusion. It says some dogs are pigs. Does my picture here show that some dogs are pigs? My dog circle would have to be kind of overlapping the pig circle at some point. It's not. I just drew a counterexample here, just based on the two premises, just like we did with E. See? This right here is invalid. My conclusion doesn't even come out or hold to be true, because I just have a counterexample right here that some dogs are pigs. It's not true. Invalid. Right? Now again, there are several ways to draw this, but you only need one counterexample. Okay? And if you first draw your first example here, drawing your first premise and your second premise, and it shows that your conclusion is not, you don't even have to draw ones because you already got that one counterexample. So note again. Okay. You only need one counterexample to show that something's invalid. Okay. We've just been drawing as many as we can think of, just so we can kind of get it down in our spirit what's happening, so we can see it. Okay. But if you see it right off, you could, by drawing, and you get it by drawing that one example, do it. Okay. That's all you need, is that one. Any questions or concerns, make sure you go to your instructor, he, whoever your instructor is, make sure you go and you talk with them, or go to Learning Commons and get some help. You can also make sure you YouTube or go to Smart Thinking and see if anyone can help you there. Lots of people are available to help you with our concepts in this class. So this is our last lesson here for Unit 3. After you finish this, you should be working on your review and getting ready for your test. Good luck with everything, and I hope the videos are helping. See you next time.